think we're doing good. So we talked about functions all this week, right? So this entire week has been dedicated to like this notation for the function. That's what our quiz is going to be on. So make sure that you're looking at that. But I think we're pretty good at doing function notation. Now we talked about function notation when we are like plugging stuff into functions, things like that. But then I started bringing graphs into it, right? So we can actually apply a function to a graph as long as it passes the vertical line test. And I was giving these like weird examples of functions. I call these piecewise functions because they're literally like pieced together bits of functions stuck together on a graph. And we talked about the domain and the range, right? Now, the domain is all the x values that a function can take on. So if I look from left to right on the x-axis, where is there a picture and where is there not a picture? For example, over here, there's no picture to the left, right? The range is the other one, the y values, right? So as I look at the graph from top to bottom, as I follow the y-axis, where on the y-axis or what y values is there a picture? What y values is there not a picture? Okay, so we did an example of finding the domain and range of the first piecewise function. Let's take a look at example number 8. So this is the graph of f. Okay, now when you take a look at these piecewise functions, just remember that if there's an open circle, it means that the function does not exist there. If there's a closed circle, it means that the function does exist there. Okay, so if I want to find what f of 1 is, let's start with that, f of 1. I'm basically asking myself, when x is 1, well, what is y? Okay, and as we go to x equals 1, there are actually two pictures here and here where the function exists at 1 and 3. What is f of 1? 1 and why would it be negative 1? I think it'd be, yeah, I think it'd just be 1, right? Because there's no picture at negative 1.
Yeah, I'm sorry.
No, you're totally fine. It's always good to make mistakes in math. You learn by making mistakes.
I don't know why I thought it was just wherever it was at.
Yeah. All right, let's do f of 2. Oh, I see what you're doing. Okay, you're doing the opposite way. Okay.
Like wherever the x value at 1 is.
Yes. F of 2. Now we're looking at x equals 2. What is f of 2? 3. Perfect, because that's the height of the function at x equals 2. And we don't look at the open circle. Okay. So it looks like we're done with that. Let's do the domain first. Okay, if I would like to find the domain, we're looking at all the x values the function can take on. So as we look at the x values from left to right, we're looking at, okay, where is there a picture? Where is there not a picture? Well, yeah, like over here, there isn't really a picture, but because we have arrows here, it means that the function keeps on going forever and forever and forever to the left. So to the left of my graph, the function exists everywhere. To the right, I still have an arrow, so the function continues on and on and on forever. So, I mean, everything to the right is good for the function. And if I take a look at where the breaks are, we break here, but I mean, the function does exist at 1, and the function does exist at 2 because we have closed circles there. So it looks like my function, my domain is everywhere. Very close, negative infinity to infinity. But when we talk about infinity, infinity is not actually a number, right? So you can't actually include something that's not a number, right? So we're going to use parentheses around infinity. Yeah.
What about the negatives? Does that just not matter?
Yeah, so if you take a look at the negatives, like there's really no picture here, but there's an arrow at the end, right? Which means that this graph goes on forever to the left. So all of these negative values are also in the domain.
So the fact that it doesn't go down.
Oh, yeah. So that's actually when we're going to talk about range. We're talking about the x values that work, not the y values. Yeah. All right. Another way you can talk about everything is you might have seen this symbol before. It's like a big R with like 2 lines on the left.
Paragraph symbol was.
Hmm?
The paragraph is that.
Oh yeah, it is kind. It's like the paragraph symbol with R. Yeah, that's true.
The paragraph is a P with 2 lines. That's an R.
Yep, and it just stands for all the real numbers. It's basically called set notation that we use for like different sets of numbers. But a couple ways you can write about this. I think this is what Alex will take. Okay, the range. Now we're gonna look up and down, right? So Dagan was like, okay, there's no graph where the y values are negative, right? Below 0, there's no graph. But above 0, it looks like since I have arrows at the ends of my graph here, it looks like there is the function exists all the way up to positive infinity if I look up and down on the graph, right? So basically, I know that the graph, well, anything below 0 doesn't work. So the things that do work is everything between 0 and positive infinity. Okay. Now, do you think we're going to include 0 or not include 0? Yeah, we're going to include 0. Even though there's no like closed dot there, if there's a line, it literally means a closed dot. Okay. So as long as there's no open dot, then we're going to include it. I have an ant on my screen. There we go. Okay, so we're going to use a bracket, right? Because we're including 0. And infinity always gets a parentheses because infinity is not really a number. Yeah.
Or the domain, would you have to break it up? Like, would you have to be like negative infinity 1, and then 1 to 2, and then.
You would have to break it up if this was an open circle, right? But the graph does exist at x equals 1. So you don't actually have to break it up, right? Yeah. Yeah, but if this was an open circle, then you'd have to break it up. Same with here. If this is an open circle, then you'd have to break it up. But we're not really going to go too far in this class. I think we're just going to stick with the basics for domain and range unless we really need it. Yeah. All right. Any other questions on domain and range? All righty, then I think it's about time to, oh yeah.
Just in case Alex, for whatever reason, decides. How, like, for example, that, like, example, have to break it up, how would you write that?
Yeah, so if the graph looked like this.
Right, let's say the 2 closed dots were open dots, how would you write that?
Okay, it would be negative infinity to 1, close the brackets, and 1 to 2, and yeah, 2 to the infinity. Sometimes it'll use like a union symbol, like an open U, if you ever seen that. But I don't think Alex will use it. I'm pretty sure I checked. Yeah. Yeah, sometimes I also don't do the best job at checking Alex to see if the homework. No, I understand the concern. I think it's all right. Let's go over lines now. Now in this class, what we're going to do is we're going to focus on different types of functions. So we're going to talk about like exponential, logarithmic, all these different types of functions. And I think the easiest type of function to talk about are lines. Okay, so straight lines is probably the easiest thing, but it's actually the most important because later on in mathematics, lines are kind of like the foundation to a lot of different topics in math. So what we're going to do is we're going to talk about how to talk about lines, how to graph them, how to apply them in different scenarios. And before we even talk about lines, does anyone remember like the equation of a line in general, Alex?
So Rod over Ron.
That's part of it.
Yes.
It starts with a y equals.
Y equals.
Yeah, mx plus b. There you go. And what Alex was talking about is one of these terms, the m, okay, this actually stands for the slope of the line, okay? And slope is rise over run, which is what we are going to talk about a lot in this class, okay? While b is just, anyone remember what b is called? Y-intercept, good. And we actually learned how to find the y-intercept in other functions as well, okay? What we're going to do in this class is we're mainly going to focus on the slope because the slope is actually the most important part of the entire equation, okay? Slope actually branches off into higher levels of math and it becomes very important later on. And what slope is it basically is a tool to describe how steep a line is. So is it really steep? Is it kind of leveled off? Does it go down? Does it go up? That's what slope measures, okay? Now, it's kind of hard to think about slope when you're just thinking about it in terms of numbers and equations and all that stuff. Even rise over run doesn't really tell you what slope actually is. But for example, if I take this into context, let's say x is time and y is temperature. How about that? okay? The steepness of any line on this graph now doesn't just tell us how steep a line is, it tells us how the temperature changes over time, okay? And this whole idea of how slope measures change is very important because when you go into a higher level of math called calculus, okay, if you ever want to take a calc class, this idea of steepness or change over time becomes increasingly important, okay? Stat is actually based in calculus. A lot of statistics is calculus. So I would say yes, that does that does involve a lot of slope. Okay, the whole idea of slope is basically the foundation for pretty much every other higher level of mathematics out there. Maybe not everything, but at least at least like the analytic calculus sort of stuff. It's all about slope, okay? And that's why it's so important. That's why I'm making such a big deal out of it. Okay, so what I'm gonna do is I'm gonna plot 2 points here. I'm gonna plot the point 1, -3, okay? And I'm gonna label it 1, -3, okay? I'm also gonna plot the point 4, 2. So 4, 2. And what I'm gonna do is, since we're talking about lines, maybe I should draw a line through it, okay? Say, I know if I didn't have my iPad, I wouldn't be able to draw a line that straight. Okay, let's say I wanted to talk about the steepness of this line. Now, before I even think about slope or rise over run or anything, taking a look at these 2 points and this line, there's actually a hidden right triangle in this picture. Does anyone see it? Yeah, right. And I know it's kind of hard to explain, but if I take a dotted line and go out from my first point and go down from my second point, what I have here is actually a hidden right triangle. Okay. And this right triangle is very nice for me because it can help me try to figure out how to find the rise and the run. Okay. Now, the rise represents how much I have to go upward to get from one point to the other. So let me write this out. We have the rise. Okay. And rise, well, how would I find out how much I have to rise to get from the first point to the second? You can count, right? So let's just go ahead and start here. 1, 2, 3, 4, 5. I guess the rise here is equal to 5. Okay. Mathematically, we don't really have to count the points or the blocks because another way to say 5 is let's just take this value 2, okay, from the y value of my first point. I'm going to take the y value of my second point, -3, and you can actually subtract them to also get 5. Okay, so you can either, huh? Counting? Yeah, why don't you find the distance between, let's do this one, -2, 1.41 to 3, sorry, 0, 0, 3.21. Now it becomes a little harder to count, right? So that's why we're trying to do it more mathematically. But yeah, counting is easier. All right, so my rise is just by taking my y values and subtracting them, right? Let's do the run. You can always count. That's always a thing you can do. So 1, 2, 3 is how much the bottom of my right triangle is. But another way to do that is to take my x value of my first point 4 and subtract off the x value of the other point 1. And we get 3. Okay. So let's try to quantify this a little bit easier, okay?
It actually matters if it was first, does it?
It's a good question.
If it was 1 - 4, it would be -3.
Huh?
I'm looking at the run. Let's say you took the 1.
Yeah, 1 - 4 would be -3. We'll talk about that.
Since it's a distance, you can't have a negative distance. That what basically it is. There's always going to be positive regardless.
No.
Okay, then I don't know.
In math, you actually can have a negative distance. It is possible.
That's weird. But
Well, how about I do this? I'm going to label each of my points. Let's make 1, -3, x1, and y1. Okay.
But how would you decide? Is it arbitrary?
Huh? It's arbitrary, yeah. And we'll talk about what happens when we swap them. Okay. 4 will be x2, 2 will be y2. Okay. Now, if I were to label what I just did here, the rise part, the 2 here was y2, right? The -3 was y1, and I subtracted them, right? So I did y2 minus y1. To get the run, I took x2 and x1, and I subtracted them, okay? So rise is y2 minus y1, and run is x2 minus x1. So yeah,
We're gonna deal with this before the test.
yeah, well, fractions. Fractions are a little bit worse than this one. All right, so another equation for slope, or m, is y2 minus y1 over x2 minus x1. Okay, and this is an equation or a formula that you do have to memorize. Okay, but it's kind of less memorizing and knowing that, okay, the rise is just the change in the y values, right? The run is just the difference between the x values, and you're just putting them on top of each other. Okay, so that's all what slope is. So let's just go ahead and find the slope of these two. Okay, so let's find the slope of this line. Okay, and just by doing the equation, I know that m is y2 minus y1 over x2 minus x1. I already labeled, let me just relabel them up here because I keep going back and forth between my up and down arrow here. So 1, -3, and 4, 2 are my points. Okay, let's make 1, -3, x1 and y1. 4, -2, we said was x2 and y2. If I plug stuff in, I get 2 minus -3 over 4 minus 1, which becomes 5 over 3. And that is my slope. Okay. Now, I had a good question. What does it really matter which one is x1 or y1 and which one is which one is x2 and y2? Why don't we go ahead and just calculate it without and just figure it out? So let's do the slope again. Okay. But this time, subtraction isn't cumulative. Yeah, commutative, sorry, not cumulative. But it's gonna play out a little bit weird. And you'll see what happens. Okay, so let's make x2, y2 be the first point, and x1, y1 be the second point. Okay, so m is y2 minus y1 over x2 minus x1. Y2 is -3 minus y1 is 2. X2 is 1 minus 4, which is x1. If I subtract this, I get -5. So subtraction isn't commutative here, but so I get negative. 1 minus 4 is -3. So what actually happened here, yeah, we can cancel out the negatives too. Okay, so you basically get the same thing. The reason it works is because you do get something different on the top and the bottom, but since we have two of them, they're divided by each other, they cancel each other out. So it actually doesn't matter if x1, y1 is the first point or the second point. The only thing that does matter is you can't put x1 with y2. Yeah. Mm-hmm.
That's the same as what you notes ago. Like, not last set of notes, just set of notes before that.
Yeah, like the distance formula, the midpoint formula, all that stuff. Mm-hmm.
I know I had the same question on that. I don't know why in my head, like.
No, it is a good question. It doesn't seem.
I wouldn't know which make, like, for looking at a graph, which one's x1 and x2?
It's not very intuitive, right? It doesn't, yeah. All right. Now, one thing I want to note is the slope is positive, and that makes sense because our graph is increasing, right? Whenever your graph is increasing, your slope is going to be positive. If the graph is decreasing, your slope is going to be negative. We'll talk about what happens when it's neither increasing or decreasing. Okay, let's do example number 1. This one is asking me to first sketch a line through the points and also find the slope. My first line here is -1, 4, so I'm going to plot that up here. My second point is 3, 2. I'm going to plot that here. And to complete my line, I guess I just have to draw a line through my 2 points here. Okay. So any preference on which one should be x1, y1, x2, y2? No. Let's just make the first one x1, y1. That seems easy. x2, y2. Okay. And if I would like to find the slope, all I have to do is remember my formula, y2 minus y1, y1 over x2 minus x1. And we're literally just plugging stuff in, right? So y2 is 2, y1 is 4, and I'm subtracting them. X2 is 3, x1 is -1. Whenever there's a minus and I'm subtracting it off, I'm going to keep it in parentheses so I'm not like, I don't know, forgetting a negative, right? All right, 2 minus 4 is -2. 3 minus -1 is +4. And we can actually simplify this to -1/2. Okay, so this time my slope is -1/2, which makes sense because my graph is going down, right? Okay. Any questions on part A? All right. Why don't you try part B now? I'm going to give you a few minutes to work on that, and then we'll come back. Yeah. All right, let's come on up to the front. I don't even know. I'm not going to give up, but this semester has really tested my limits today. Oh my goodness. I knew you were Becca. I'm so sad. Okay. Becca did a very nice job of finding this slope, and I did a very bad job of remembering her name. But I like how she plotted her points and drew the line through it. Uh-huh.
Isn't it -2, -1, not -2 points?
Where?
4 point each, the lower. That's not the difference.
Oh, wait, that is true. I wasn't even paying attention. I'm so sorry, Becca. Oh, yeah, it should be this one, right? Yeah, thank you. Oh, no, you're
Sorry,
totally
I
fine.
didn't confuse me.
Yeah, because I looked at yours. I didn't see anything. I feel like I would have caught that. Maybe I would. Maybe I wouldn't have. All right. But I really like how she plugged everything in, got 3/2. Any questions on how Becca got part B? All right. So let's keep going. If we flip the page over, we have 2 more points. We have 4, 3 right here. We have -2, 3 over here. If I draw my line straight through, let's do that. Oh, that did not turn out very well. Let's do that again. Here we go. Okay, this is my line, and oop, it's not increasing or decreasing, right? So definitely can't be a positive slope, definitely can't be a negative slope. Let's see what happens when we go and find the slope, okay? So what I'm gonna do is I'm gonna make the first one x1 and y1. I'm gonna make the second one x2 and y2, and let's just plug into the formula. y2 minus y1 over x2 minus x1. So y2 is 3, y1 is 3, x2 is -2, x1 is 4. So 3 minus 3 is 0, -2 minus 4 is 6. What is 0 over -6? A lot of stuff. Yeah, it's got to be 0, right? Now, this kind of, I kind of get confused if it's 0 or if it doesn't exist or something like that. If you ever get confused as to what this is, you're allowed to bring your calculator to the exam, right? So if you ever get confused, just plug it in your calculator. If it gives you 0, then the answer is 0. Yeah. Where's -4?
It's -4. It's -5.
Yeah, minus +4. Yeah, gotcha. So actually, this isn't a coincidence, okay? Whenever you have a horizontal line, the slope will always be 0 because when you subtract 2 points that have the same y values, it becomes 0. Yeah. Oh, did you have a question?
No.
Oh, okay. So in general, a horizontal line has slope 0. Okay. I think you know. No, I just have it up here just because I feel like whenever I go back in my notes, like whenever I'm in class, like I understand it in the moment, and then when I go back and read my notes later, I just like have no idea what I just did, which is why I always write stuff on here, even if it seems self-explanatory. All right, part D. Let's plot 4, -1 and 4, 4, and I'm going to draw my line straight through these. Uh-oh, now we have a vertical line. Uh-oh. Let's see what the slope is going to be this time. So is it going to be 0? I don't know. Let's make 4x1 and -1 y1. Let's make 4x, oh my gosh, x2 and 4y2. Okay. Let's plug it into the formula. y2 is 4, y1 is -1. x2 is 4 and x1 is 4. So when I subtract these two, I get 5 over 0. Yeah, this isn't gonna have a solution, right? Because if you divide 5 by 0 in your calculator, it's either gonna say error or it's gonna freak out on you. It's not going to tell you the answer. This actually cannot happen, okay? Yeah.
It doesn't matter, like, if I wouldn't make like 4y squared, it doesn't matter.
Oh, so what was your question?
Like X1, Y1, like all those, like, it doesn't matter which ones are which, like, it doesn't matter, I can put like Y1 on 4.
Oh, yeah, so you can make 4x2 and 1y2, but you can't like switch it any more than that, right?
Okay.
Because x1 has to be with y1 and x2 has to be with y2. Yeah, but you can swap it around. All right. So this is actually something, well, you can't divide 5 by 0 because imagine taking a pizza and cutting into 0 slices, right? That wouldn't work. So this is actually a case where the slope is undefined. Okay. That's usually how we call it. Okay. And I guess, I would say that it's not really a solution. It's more like, I guess the slope is a solution. But normally how we talk about it is we say that the slope is undefined. Okay, so any vertical line actually has this property where if you ever see a vertical line, it doesn't even have a slope, okay? The slope is undefined. We don't talk about slope with vertical lines. Okay. Any questions on part D?